And this video is going to be obviously like a practice quiz on the exponents, on the 7 rules of exponents. Let's jump right in. Feel free to jot these down as we go. The first one, very simple. Parentheses do make a difference. So you have -5 to the second power. Now what that really means is that you write the base -5 2 times. And obviously -5 times -5 is positive 25. Okay? So you're going to see a question like that on the quiz, right? Hopefully you understand. Now if you don't have parentheses, like right here there's no parentheses, so that's not really a -3 to the second power. That's really a 3 to the second with the negative sign in front. Okay? I've already explained this before. Like if you had a negative x, right? Everybody knows, we've seen a negative x before. What the negative x really means, and this is not part of the problem here, but I just want to elaborate. What negative x really means is -1 times x. So whenever you do have a negative in front of anything, it kind of means -1 times, right? So -1 times x. In this case, it's saying -1 times 3 to the second power. And if we think of PEMDAS, you got to do exponents before multiplication. So that's why we do 3 squared first, and that's really a 3 times 3. And the negative sign, we just put that negative sign in front of our answer. So in this case, it's going to be a -9. Okay? So when the negative sign is included with parentheses, and that truly is the base -5, and you do that many times. -5 times -5 equals 25. When you don't have parentheses including the negative sign, the base is really a 3, and the negative is just out in the front. So that's why your answer is -9 there. Okay, how about number 3? That's applying rule 1. And of course, you could rearrange things if you'd like to make it easier for you. It's all pure multiplication, and commutative property of multiplication allows you to rearrange things. So you could do this in your head. The 2 times 3, you know you're going to get 6. And the x to the 7th times x to the 4th, we know rule 1 says that you got to add those exponents because we are multiplying with the same base. So the final answer is, for this one, 6x to the 11th. That is your answer for number 3. And all of these questions are going to be very similar to the ones you're going to see on the actual quiz tomorrow. Moving on to 4, 5, and 6. Number 4, again, you could rearrange it, or you could get comfortable doing it in your head. Like, let's start with the coefficients, right? The numbers, the 4 times 3. 4 times 3 is 12. And then you could move on to the x's. We have x to the 3rd times x to the 4th. And we all should know that we're multiplying with the same base, so we're going to add those exponents. That'll be x to the 7th. And last but not least, we are going to multiply the y's, the y to the 2nd right here and the y to the 6th. Add those exponents, and you get y to the 8th. And that is your final answer for number 4. Moving on to the next one, number 5. In this one, we have that next rule that a power to a power, you multiply. So it's as simple as that. 2 times 4 is 8. So your answer is x to the 8th power. Power to a power, multiply. Okay. Now, comparing number 5 with number 6. Number 6, we have parentheses around all of this, and right here it's parentheses just about that single x squared. So yeah, you multiply power to power, but down here there's 3, there's x, there's y, there's z. So you got to distribute that outside exponent to each inside term. This is technically rule 3/4, because both rules say that you distribute the outside exponent to each inside exponent. Now remember, this is not a 3 times 3. You should not write a 9 out here. That's incorrect. There's really an invisible power of 1 on 3, an invisible power of 1 on x. So when you distribute power to a power, you multiply. So 3 times 1 is 3. So what you really have is 3 to the 3rd power. And then we distribute 3 times x, and then we'll have x to the 3rd power. Again, because 1 times 3 is 3. And then we distribute and get 3 times 4. That'll be a y to the 12th. That was weird. My voice went. And last but not least, we are going to distribute 3 times 2 and get z to the 6th. Now the only other thing we could do is actually multiply or do the 3 to the third, which is a multiplication of 3 times 3 times 3, which is what? 3 times 3 is 9, and 9 times 3 is what? 27. So our final answer here will be 27, x to the third, y to the 12th, z to the 6th. Okay? I hope we see that. Now here's the last, whoops. Sorry about that. Let me just get this out of the way. Here's the last one on this slide. This one is extra fun. We are again distributing the outside exponent to each and every inside exponent. Same thing over here. So we're going to distribute, and then after that, we're going to multiply the like terms, the x's with the x's, the y's with the y's, which applies rule 1 where you add exponents. So let's begin with distribution. The power of 2 is going to go on the 3, that's 3 squared. Power of 2 is going on the x squared, multiply power to a power, x to the 4th. 2 goes on the 4, power to a power, multiply 4 times 2 is 8. Let's do the same for the other one. Distribute the 3, that's going to be on the 2, that's 2 to the 3rd. 3 times 3 is 9. 3 times 2 is 6. Okay? Now we are multiplying between the first and the second, so we will be multiplying between this guy and that guy. And it's all pure multiplication. So in reality, we should be multiplying the big numbers. 3 squared. What's 3 squared, by the way? 9. Okay? And what is 2 to the 3rd? 2 times 2 times 2? 8. Okay? So what we're really multiplying here is the 9 times 8. 9 times 8 is 72. You could use a calculator if you need it. What about the x's? Well, we have x to the 4th times x to the 9th. Add those together, you get x to the 13th. And then we have y to the 8th and y to the 6th. Add those together, and you get y to the 14th. Ladies and gentlemen, that is your final answer right there. So this is actually rule 4, very similar to rule 3. You have parentheses with an exponent on the outside. You need to distribute that outside exponent to each and every inside exponent. So the 2 is going to be right there, and you're going to multiply. You're going to end up with the x to the what? 6th, okay? Over, distribute the 2 down here. Now, it's not a 2 times 3, so you're not going to put 6 down here. It's actually a 3 to the 1 power, right? So you're multiplying the 2 times 1, so that's going to give you a 3 squared down there. 3 squared down there. Now, what is 3 squared? 3 squared is really 9 on the bottom, and the x to the 6th stays on top. That's your final answer right there. X to the 6th over 9. Moving on to the next one, almost identical process. You take the outside exponent of 3 and put it on each and every other exponent. So you're going to put the 3 right there on the 2. That'll be a 2 to the 3rd. We're going to put the 3 on the 6. 6 times 3 is 18. So you have x to the 18th. And it's over. Distribute the 3 to the 3. That's going to be a 3 to the 3rd. Distribute 3 on the 5. That'll be a y to the 15th because of power to a power you multiply. And the only other thing you could do is change your numbers with exponents to actual numbers, right? 2 to the 3rd is 2 times 2 times 2, which is 8. And then you have the x to the 18th. And down here, 3 to the 3rd, that's 3 times 3, 9 times 3, 27, and y to the 15th. And there's your answer for that question, which is purely rule number 4. Finally, we're getting to the rule with the power of 0, right? What we need to remember is that anything to the power of 0 equals 1. Okay, now that's super easy, but it could be slightly confusing if you're working too fast, right? If you're thinking anything to the power of 0 equals 1, well then this obviously x to the power of 0, that equals 1. Okay? But the next one, if you think about it too, if you're not thinking about it, you're probably going to put 1 and that's going to be incorrect. But the bottom line is it says 2 times x to the 0. So obviously you have to deal with exponents before multiplication. So you're going to do x to the 0 first. X to the 0 is 1, but the 2 is out in the front. So it's really 2 times 1. So your final answer there is 2. So number 11 here, 2x to the 0, the answer is 2. 5x to the 0, the answer would be 5. 7x to the 0, the answer would be 7. I hope we see that. Number 12, you have 0 as an exponent, parentheses with some junk on the inside. Now, the whole thing is in parentheses to the 0 power, so the whole thing to the 0 power equals 1. Okay? Last but not least, when you're faced with a situation like this, anytime you have a power of 0, you could just scratch it out, right? You could just scratch it out, because we know that x to the 0 is 1. So it'd be ridiculous writing it like this: 3 times 1 times y squared times 1. That'd be ridiculous, right? It's better to just scratch it out and say that your answer is what you have left over, 3y squared. So again, when you have x to the 0, you can just scratch it out. You don't even have to write, it'd be ridiculous to put the times 1, because we already know 3 times 1 is 3, and times 1 is still going to be 3. So those 1s are unnecessary to write. Now we finally get to the rule that has negative exponents. Anytime you have a negative exponent, you must grab the term with the negative exponent and move it to the other side. Only the variable or the term that has a negative exponent. So on number 14, the only thing that has a negative exponent is that x value. So circle it, draw an arrow to the other side. The other side of what? Go ahead and make a fraction. So obviously, the 2 stayed up on top. You didn't move. On the bottom, that x to the negative 3, it came down and it became x to the positive 3, and we're done. That's an answer right there. Now, number 15, you have parentheses, 2x with the negative exponent on the outside. You could either distribute the negative 3 to both terms and then move them both down, or you can move the whole thing down and then distribute. I'm going to go with distributing first. So I'm going to end up with a 2 to the negative 3 times x to the negative 3, right? And that's going to now be moved down to the other side. So I make a fraction bar, circle this guy, move it down, circle this guy, move it down. So obviously there's nothing left up on top, so I put a 1 up there. Then you have your fraction bar, and on the bottom you have the 2 to the positive 3 and the x to the positive 3. Now the only other thing you could do to make this answer look nicer is to do the 2 to the third power, which would be 2 times 2 times 2, which would be 8. So you really have 1 over 8 x to the third. That is your answer for number 15 right here. Number 16. Where's the negative exponent at? It's at the bottom. So we need to grab this guy and move it up. I highly recommend circling and drawing arrows. Not only that, you could actually rewrite it up here, put the x up on top. Now normally you want your answer, normally you always want your answer in alphabetical order. So don't just put it right here, put it over here between the 2 and the y. So your answer will be the 2 stayed up there, the y stayed up there, but that x to the negative 3, we're going to plop it right here. So it's in alphabetical order. 2xy to the x to the third, y to the fourth. And technically there's nothing left on the bottom. You could put it over 1, but that's a waste of time because that's simply just the answer, 2x to the third, y to the fourth. You don't need it divided by 1. So this is your final answer for that question. So we have a couple more negative exponents, and we're going to eventually get to mixing rules like negative exponents and the canceling rule, right? So number 17, we want to get rid of that negative exponent. That x to the negative 2, we're simply going to circle it and draw an arrow, move it to the other side. And check this out. I might as well write it right here, x to the positive 2. And since I already moved it, I could just draw a line through it because it's no longer at the bottom. I already moved it to the top. And that tells me to apply rule 1, that when you're multiplying two terms with the same base, you could add these exponents. So my final answer will be x to the 7th. And you could put it over 1, but that's ridiculous. You might as well just say x to the 7th. Whenever there's nothing left underneath, you don't have to put the 1 under there. But whenever there's nothing left up on top, you have to put the 1 up there. Okay? Here's an example of that on number 18. Again, the canceling rule is stating I have 4 x's up on top and 7 on the bottom. All 4 x's could cancel with 4 of these, and you'll have 3 left over on the bottom. So instead of expanding, I'm just going to say, I know that all 4 x's are going to cancel out. And that's why I draw a line all the way through the x's, not just the 4. I go all the way through the 4 and the x's. All 4 x's are gone. They're gone with 4 of these 7. And notice I didn't go through the x because there's still 3 left over. So there's my answer. There's nothing left up on top, so I put a 1 up there. You have to put the 1 up on top when there's nothing left. On the bottom, you'll have x to the third. So there's your answer for number 18, 1 over x to the third. Let's move on. 19. Again, we're canceling. 3 x's on the bottom, 9 x's up on top. All 3 x's. That's why I draw a line even through the x. Not just the 3, but even through the x. 3 x's cancel with 3 of the 9, leaving us 6 up on top. So the answer, up on top, you have x to the 6th. On the bottom, you have nothing left, which means you don't have to write it. It's only when there's nothing left up on top that you have to write a 1. But if it's divided by 1, if you actually divide something by 1, it'll be that same something. So you don't have to write it over 1. Moving on to the next one. Oh yeah, it's getting fun. So there's different rules we could apply. We could also begin by looking at the numbers and imagining that that was the only thing you see, a fraction 35 over 5. If you saw the fraction 35 over 5, what's the answer to that? 7. And obviously it'd be up on top, right? Because the 35 is up on top. If the 5 were on top and 35 on the bottom, then it'd be a 7 on the bottom. But since the bigger number's up on top, 35 divided by 5, 7 up on top. Now we could move on and look at the x's. Well, there's 1 x on the bottom that will cancel with 1 of the 5, leaving us 4 left over up on top, x to the 4th. And then the y's, we need to apply the rule of negative exponents where we move them. So this y to the negative 8, it's going to go down and it's going to become y to the positive 8. And this y to the negative 10, it's going to go up and it's going to become y to the positive 10. So I already scratched it out. I'm scratching it out because I did move it down already and change it to positive. I scratch it out because I already moved it up and changed it to positive. And now from here, I have 8 y's on the bottom and 10 y's up on top. That means that all 8 y's, all of the 8 y's cancel out with 8 of the 10, leaving us 2. Again, because all 8 y's cancel out, I even put my line through the y. There's no more y's. Up here, I only draw it through the 10 because there's still some y's left. How many? 2. Because 8 and 10 take away 8 is 2. So we have y squared up there as well. And what do we have on the bottom? Nothing. So I could put a 1, but that's ridiculous. It's better to just write it 7, x to the 4th, y to the 2nd. We're on the home stretch here, guys. We have another 5 questions, 21 through 25, and then we're done. So 21, we could cancel things out, right? I could cancel out this x up on top with that x on the bottom. I also have y's. 2 y's up on top could cancel with 2 of the 5, leaving us only 3 on the bottom. I always write my fraction bar. What do I have left up on top? The 2. What do I have left on the bottom? Just the y to the 3rd. And there's your answer, 2 over y to the 3rd. 2 over y to the 3rd. Number 22, that one is fun. Now, normally, when we have parentheses, we work on the inside of the parentheses, which I highly recommend you do. But technically, you don't have to. Like, whatever rule you see, you could apply that rule. If you wanted to take the negative 1 and distribute it to the 3, to the 8, to the y, to the 2, to the 4, to the 3, to the 0, you could do that if you want. But I recommend zooming in and working just on the parenthesis, like on the inside of the parenthesis first. Like make it smaller, that way it's easier to do when you distribute that negative 1 later. So obviously the x to the 4th on the bottom and the x to the 8th up on top, this guy and this guy, they're going to eliminate. All 4 x's cancel out, that's why I draw a line even through the x with 4 of the 8, leaving us 4 left over up on top. That's why I didn't cross the x out, because there's still x's left over, 4 of them. Now, I cannot cancel the y with this y, because this is not a regular y. This is a y with a negative exponent. And we all should know that anything with a negative exponent, you must grab it and move it to the other side. So when I move it up, it's going to become y to the positive 3. Okay? And I could scratch it out because I already moved it up and it became y to the positive 3, right? How about the z to the 0? That's a rule that I could apply. Anything to the 0 power is equal to 1, so that just eliminates. Okay? And what else could I do here? Well, up on top, I could actually say y times y to the 3rd. That's rule 1. So I really have y to the 1 times y to the 3rd. When I multiply y to the 1 times y to the 3rd, I add those exponents, and I'll get y to the what? Y to the 4th. Okay, so let me rewrite what I have so far. I have the parenthesis. I have the 3x to the 4th. I have a y to the 4th. And it's over what's left over on the bottom? Just 2. Okay? Now, don't forget about the negative 1 that's still on the outside. So a negative 1 still on the outside. So now we could distribute that negative 1 to each and every term on the inside. The negative 1 is going to be on the 3, so that's 3 to the negative 1, x to the negative 4, y to the negative 4, and 2 to the negative 1. Technically, what does that do to all your terms? It flips them all around from the top to the bottom, from the bottom to the top. So our final answer, and I'm kind of skipping my work here, my final answer will be 2 up on top, 3x to the 4th, y to the 4th on the bottom. That's it. Now, I apologize, I did skip some work because that should be right here, 3 to the negative 1, and then you would circle it and then move it down, become 3 to the positive 1. There it is. Distribute x to the negative 4, circle it, draw an arrow down, x to the positive 4. Distribute negative 4 right there, y to the negative 4, circle it, draw an arrow down, it's right there, y to the positive 4. Negative 1 right there, 2 to the negative 1, circle it, move it up, it becomes 2 to the positive 1, which is just 2. Moving on to more fun questions. Number 23. We have x to the 0, which is 1. So if you want, you can just scratch that out. And then we have x to the 2nd times x to the negative 7. So what do you want to do? You could use rule 1 and add those together and get x to the negative 5, but then you'd have to move it down. Or you could start with the negative exponent, x to the negative 7, and move it down to the other side and make it positive, x to the positive 7 down there once you move it. Okay. Now from there, you have x's on top and x's on the bottom. There's a total of 2 x's on top and 7 x's on the bottom. So right there you would cancel both x's that are on top with 2 of the 7, leaving you 5 on the bottom. So our answer is going to be a fraction with nothing left up on top. So we put a 1 up there. And on the bottom you have the x to the 5th power. Moving on to number 24. Again, anytime I see anything to the 0 power, I just scratch it out because that becomes a 1, right? It's pointless to say negative 10 times 1. We already know it's going to be negative 10, so just scratch it out. It deletes, it eliminates, it's gone. What else could we do? We could cancel things out. We cannot cancel out x's yet. Why not? Because that's a negative exponent x. The only way you could cancel out x's if you have regular x's on top, regular x's on the bottom, and that's not the case here, okay? I could cancel the y to the 2nd with the y to the 5th. Those are regular y's. So 2 y's cancel with 2 of the 5, leaving us 3 left over up on top, okay? And in addition to that, we're going to move the negative exponent of x to the 3rd. We're going to move it down, and it's going to become x to the positive 3. And you could scratch that out if you moved it down and became positive. Okay, so what do we have left on our answer? Well, up on top we have negative 10 and y to the 3rd. Let me write that. Negative 10, y to the 3rd. And on the bottom we have 2, x to the 5th, x to the 3rd. So I might as well apply that rule that says when I'm multiplying with the same base, x here and x here, we could add the exponents 5 and 3. That would give us 8. So we really have a 2x to the 8th. Now, for my last step, I'm done with the rules, but I still have an actual fraction right here. If you take a look at that fraction right there, it says negative 10 over 2. And you could actually do negative 10 divided by 2. What's negative 10 divided by 2? 5, negative 5. So you could scratch it out, put a negative 5 up there, right? So here's my final answer. Let me write it. Where do I write it? I'll write it down here. Negative 5, y to the 3rd over x to the 8th. Negative 5, y to the 3rd over x to the 8th. And moving on to our final question of the day, number 25. Whoa, went too far. Come on back down. Where are you? There you are. All right, so we have parentheses. We have an exponent on the outside. What am I going to do? Distribute. That's right. So we're going to take this power of negative 3, put it on the 2. That'll give us 2 to the negative 3. Distribute the power of negative 3, put it on the negative 4. Power to a power, multiply. So you're going to have x to the negative 4 times negative 3, positive 12. And then distribute that negative 3 to the y, and that'll be y to the negative 3. Okay? And that is still over 7x to the 10th y to the 2nd. Okay? So next, I am either going to do the canceling rule with the x's, or I could move negative exponents down to the other side. It's totally up to you guys. What do you want to do? Cancel. All right, so 10 x's on the bottom completely cancel with 10 of the 12, leaving us 2 left over up on top. Okay? Now, in addition to that, we're going to move the negative exponent term down here, making it 2 to the positive 3, and then times 7. But since I already moved it down, I could scratch it out. It's no longer up there. And then I'm also going to move y to the negative 3 down here, and I want to make it y to the positive 3. And since I already did that, I could scratch it out. It's no longer up on top. So let's write our, well, close to final answer here. Up on top, there's no more number. There's an x squared. That's it. So I'm going to write x squared up there. And on the bottom, I have 2 to the third. What is 2 to the third, by the way? 2 times 2 times 2. 8. So I really have 8 right here times 7, right? We really have 8 times 7 right there. And what is 8 times 7? 56. So there's a 56 down here. 56 down here. What else is down here? There's no more x's, but we do have y to the 2nd times y to the 3rd. What is y to the 2nd times y to the 3rd? Y to the 5th. That's right. You add the exponents when you're multiplying with the same base. And ladies and gentlemen, this is it. If you understand everything I've just covered, you're ready for an A+. Wait, actually, I shouldn't say that. If you understand it and you practice, you're going to be ready for an A+. Because if you just understand it and you don't practice, you're probably going to make some mistakes. So get to it and practice.